So this faded out slide here is a bunch of workers in China making Roombas, the vacuum cleaning robot made by iRobot, a company that I was co-founder of, with very low technology, simple fixturing, and low cost manufacturing. And I'm going to talk about three things today. That there are powerful reasons for reshoring manufacturing to the US, but conventional robotics won't do it. Secondly, I'm going to talk about a new class of robots that are around today in many different industries, collaborative, interactive, and safe robots that are going to enable many new applications, including manufacturing, and I'll show you some of those. And thirdly, that at my company, Rethink Robotics, and I had the name Rethink Robotics before I heard the name of this conference, just to be clear. We're changing manufacturing with these robots, but I think that changing demographics is going to really drive the demand for robotics in ways that we're only just starting to see. Demographics, the turnabout is going to really change our whole lives. So if we go back to just after the Second World War, into the 50s, the US started to outsource manufacturing to Japan through a pull method. Small companies in Japan, innovative companies, which became global brands like Sony, Toyota, et cetera, started manufacturing at much lower cost in Japan and pulling manufacturing to Japan. As the standard of living, as the economy recovered in Japan, the standard of living went up, other competitors came into play. People may have heard of a company called Lucky Gold in Korea. Does anyone know Lucky Gold? Yeah, it's now renamed LG. So LG, Lucky Gold, was an OEM manufacturer along with Samsung. They became global brands. And as that standard of living went up in Korea, manufacturing got too expensive, and a bunch of entrepreneurial little companies in Taiwan started doing outsourced OEM. Some of them became brands like Acer. Others are less well-known. Quanta Computer makes a lot, about probably half the laptops in this room were made by Quanta Computer, but they have not become a brand themselves. As the standard of living went up in Taiwan, manufacturing became too expensive in Taiwan, and now it moved into southern China, but it moved in two ways. Those Taiwanese companies largely ran manufacturing, and a few Hong Kong-based companies. Very little native companies in mainland China, except for one, Legend. People may not have heard of Legend. They started by importing IBM PCs when you had a character-generated card, and they built Chinese character-generated cards, and eventually they built more and more of the PC and became Lenovo. So that's really the only real success story in the electronics area in China as a native brand. But manufacturing is getting too expensive in China. When I was manufacturing toys in the late 90s in China, it was already too expensive to do the plush, the sewing in China. We already had to do that in Vietnam, and you see more and more manufacturing move to Vietnam. But then you run out of space because the Japanese did an end run around into Thailand and other countries. Last year, 2012, Thailand was the 5th biggest market in the world for conventional industrial robots. And it's because of Japanese manufacturers being in Thailand. So we're running out of places to push low-cost manufacturing. So there's a lot of arguments for reshoring to the US. One is productivity. If we can increase productivity, it beats cheap labor, because cheap labor keeps getting more and more expensive in the places we've been exploiting. Second is responsive short supply chains. If you're manufacturing consumer goods in China, you really have to say 30 weeks ahead of time how many items to manufacture, but you have to say how many items for each retailer, because Costco wants a different pack out. They want to pack out with a lot of stuff. Sears wants a different pack out. One time when I was still at iRobot, we had a whole bunch of Roombas packed out for linens and things, which went under while our goods were on the ocean. Protection of intellectual property. Anyone who's manufactured low-cost goods in China certainly had terrible problems with protection of intellectual property. Lower transportation costs, but the most important thing, I think, is if you manufacture a long way away, the innovation happens close to manufacturing, so you're outsourcing the innovation too. And a lot of companies have woken up to that. So they want to pull manufacturing back into the US, and we see that sort of every day in the news right now. And the president's initiative is part of that whole process. So could we get productivity to beat cheap labor in the US through the use of robots? Well, conventional industrial robots have really gotten stuck in a time warp from 1961, when the first industrial robots were built by a company called Unimation. Joe Engelberger, the founder of it, is still alive. First used in a GM plant in New Jersey in 1961. Computation was really expensive. Sensors were really expensive. So these were dumb robots that just followed a trajectory repeatedly again and again. And in the last 50-some years, they've gotten really good at that. They now have microprocessors inside them running Kalman filters, modeling the wear on the gears, et cetera. But they can follow trajectories very accurately, very precisely, again and again with no servicing for, say, 10 years at a time. But other sorts of sensors, other sorts of algorithms are not vertically integrated with them. You need systems integrators to bring them in, and then you need specialized programmers. And your hammer is following trajectories accurately, and you have to structure your process for that. The robots aren't sensing things outside them, so they're dangerous. There's no people in here. 70% of industrial robots are in automotive, and they're mostly in the body shop. This is a clip from a body shop, or in paint. If you go to the final assembly line in an automotive factory, it's all people, no robots. These places, it's all robots, no people. They don't mix. So the reality of industrial robots, for instance, is that there's 300,000 small manufacturing companies in the US, less than 500 employees, and almost none of them have robots, because to amortize the cost of setting up a production line, it has to do the same thing again and again and again for years at a time. I was at a meeting not too long ago with Yaskawa, one of the big Japanese industrial robot companies. Very innovative. The head of technology in the US was sort of scratching his head and saying, some of our customers want to run a line for only 4 months before they change it. So it's only viable in industries which are doing something the same for a long time. There's a lot of barriers to entry, a lot of other contractors, a lot of people you need to bring in. So I decided that based on what was happening in robotics outside of manufacturing, maybe things could change. Here are some pictures of robots that have appeared since around 2001. Top left there is Intuitive Surgical. Ken Salisbury, who's going to be up here on stage next, was it science advisor for 4 years to this company. And here a surgeon is using the robot, and the robot is interacting with an ordinary person there on the, in a very intimate sort of way. It's inside the person. So robots and people working together. Over here on the right-hand side, this is the Kiva system. Kiva was acquired by Amazon for $775 million last year. It's a company based out of Boston. It's for fulfillment centers. And there was a great example of partitioning a problem into what a robot couldn't do and what a robot could do. Conventional fulfillment centers, people have to go along between rows of shelves and pick out items. They don't actually pick out an order per se. They pick out lots of items, which then go through a secondary sort later. But they have to travel a lot and pick out items, and then they get resorted and go to the actual final packaging. But the brilliance of Mick Mounts was that he realized that robots, these orange things here, were really good at traveling in straight lines, but it was really hard to build a robot that could pick something out of a bin. So what the Kiva system does is brings the shelf to the person, the picker. The person picks, a light goes on which shelf they're supposed to pick out of, and then the shelf goes away. And they just stand there and shelves flow to them at a great speed. And so the person does the bin of parts pick, which is hard for a robot. The robot moves stuff around, which is easy for a robot. One of my, iRobot, a company I also co-founded, made the Roomba. It's not really something that a person interacts with much, but operates in the home. Over 10 million of them are out there right now. So people and robots in the same space. And down here are military robots, which have the US military has gone from 0 ground robots in June of 2002 to over 12,000. All these robots here happen to be made by one of my companies, iRobot, doing a bomb sniffing. Back in 2002, US military doctrine was when there was a suspected insurgent bomb, you put someone in a bomb suit, they go out and poke it with a stick. No longer allowed. You have to send a robot out. Sometimes the robots blow up. This is a robot, Scooby-Doo. This is the back of Scooby-Doo's head. It had been through 17 missions for IEDs, improvised explosive devices, one for VBID, vehicle-based improvised device, and one for UXO, unexploded ordnance, before it finally blew up rather than the soldier. This is actually a depot worker. Soldier brought in and said, "Can you fix Scooby?" They said, "No, but we can give you another one." And the guy said, "But this is Scooby. We've been through a lot together." And we saw that again and again of a bonding between people and their robots. And then the smaller SUGVs now going in with troops as forward and rear point person in small troops in urban environments. So people and robots working together. And we've heard a lot of stuff today about how robots, or how manufacturing is complicated. You need better education. The key to all these robots, except I can't speak for Intuitive Surgical. I don't know about that. But for all these other robots, the key was to make them easy to use.